Hello everyone. That's the second part of the sequence of videos about HVAC systems in COVID-19 times. In the last video, we discussed a little bit about contamination control and gave an overview about the techniques that we use as engineers to control contamination and reduce spread of microorganisms in installations. And now we will enter more specific topics, and we will start discussing a little bit about the filters that are used in the HVAC system. So when we remember about the size of the particles, there's a lot of mysticism and guessing in the market about, oh, the virus is too small and the particles are too small, so not even HEPA filter would be not capable of retaining the virus, and that's not the reality. The small particles, even the smaller particles that are below 1 micrometer, they can, and they stay floating in the air, they can be captured by filters. And we will show here in this next couple of slides how it works. So now here we have two pictures of a microscope showing the fibers of filters. And you can see that in this, the picture that's below, we can see smaller particles attached to the fibers. That means that even the smaller particles that go fly through the fibers, they will be catched and they will be attached to some fiber. And we will see the mechanisms that are the most important mechanism in the filtration technology theory. And the nice thing about filters is that the filters they capture, they don't care what is coming through. If it's a viable or non-viable particle, for the filter it's the same. So it will deal with them and capture these particles. So if we look into the mechanisms of capturing and retaining material in the filters, the first one, and that's quite intuitive, is a strain. So we have the fibers and the particle is not able through the size to go through the fibers. So it comes with the airflow current, and the space between the fibers is too small, and then it gets captured. That is true for the biggest particles that we have, like powder, atmospheric dust, and so on. In the first stage of filtration, that's the mechanism that we use. The second one is the inertial impact. This particle comes with the air current, and it's not able to make to follow the flow. So it's like something, a rocket in the water or something that's going through, and it cannot make the curve, and then it hits a fiber. So that's inertial impact. The third important mechanism that we have to capture particles is the interception. So the particle begins to move around the fiber with the airflow, but there are some attraction forces between these particles, and then it gets attached to a fiber. And the one that's the most important for the smaller particles is the diffusion, the Brownian effect. We have this small particle, and we have here the air currents coming in direction of the fiber, and we can see that this particle comes floating around. So these particles, they have a high probability in HEPA and Hoopa filters to get attached to a fiber, and we will see that through the efficiency graphics. So here we can see all the effects together, and here's our fiber, and we can see that the diffusion one can also be attached to the back side of the fiber. In some filters, we have also electrostatic effects. So there is a possibility electrostatic and electric attraction effects. Not that usual now, but still can happen. And what happens with that is that the efficiency, the total efficiency from the filter, it is a combination of all these mechanisms that the particle has. So first, for the bigger particles, is the interception and strain, and the attraction. And then for the smaller particles, the efficiency increases for the smaller particles with the Brownian effect. So the efficiency from the filter usually is a curve like that. So we have one particle size where the efficiency is lower, but for the smaller particles, the efficiency increases again. And that's quite important. So HVAC systems and HVAC filters, and mainly the HEPA Hoopa filters and the high classes MER filters, or the old F9 from the European standards, they have a efficiency that increases for smaller particles, and we can see that. And we will see that in some pictures from reports and from the standards itself. So how are the filters classified in general? We have standard filters and we have the absolute filters that are dust filters, coarse filters, and fine dust filters. So that is our MER filters are in this classification. And then we have the HEPA and UPA filters. And how do we apply these filters? Usually this kind of filter is a filter that we use as pre-filtration, and they are designed to capture particles that are bigger than 10 micrometers. They are to capture insects in the air, fibers, sand, ashes, big particles. And they usually are the pre-filtration in installations that have other stages of filters, like with these filters and these filters. Also, that are the kind of filters that we have in our houses, in our Hvac system in the houses and in the small mini split system. And so it's really low grade filtration devices. And when we go to the fine filters and we go up, then it's for the smaller particles. Now we are talking about 1 to 10 micrometers. That we are already extracting pollen, cement, and bacteria and some germs. We will see from the graphics that that's not that like for microorganisms, it's not like efficient as an HEPA filter, but they help. And they are used in workshops, in offices, in supermarkets. So then we come into this kind of filtration devices. And when we go to what is clean rooms and hospitals, then we are talking about HEPA and UPA filters. So, but every installation that has an HEPA and UPA filter will have some stage of filtration before it, because we want to protect the HEPA filter from the bigger particles, because it will clog the filter really fast. So the filtration system consists of a stage or steps of filtration. So first we have a pre-filter that's for the bigger particles, and we work more with the strain type of retention. Then we have the fine dust filters, the MERV 13, MERV 11 to MERV 16. And then we have already some interception and some effect of diffusion. Then we have the HEPA filter, and really what we want to do in the HEPA filter is capture the particles per diffusion, or I mean, the really, really small particles. So we always have a pre-filter to protect this one, because these filters are more expensive. So we use these filters as a pre-filtration to catch the big matter, the big particles, and they're less expensive, so we can replace them more with lower cost, and then we optimize our installation. But it's important to know that the filters, they have different standards and all around the world, and we need to be able to understand the difference between them, so that we can look into different suppliers all over the world. What's in today for coarse and fine filters, the pre-filtration, the important standards are ASHRAE 52.2 and the ISO 16890. They are still referenced to EN 779. There is a transition period. It's almost over. So it's an obsolete standard. So all the European companies are moving to the ISO standard. And unfortunately, we still see some references to ASHRAE 52.1, but it was replaced by 52.2 several years ago. It's important to consider that for these filters, we do not make tests of each filter at the end of the manufacturing. The tests that we do with these filters, they are destructive tests. So after the test, the filter is not usable. And that's the reason we develop the filter, we do the testing, we get the classification, and then we do test, at the big companies, we do tests for quality control and to keep the filter, to know that the filter is still, the media is still what the supplier says. And there are some neutral agencies that do filter certification, and in Europe, that's the Eurovent. So the filters that come with a stick Eurovent, that means that Eurovent goes to the market and buys some filters every year, and they test them, and then they validate it against the catalogs from the suppliers. So with these new standards, what the particles that are tested is 0.3 to 0.10, that means a full range of the particles. And then they will be classified through efficiency for the different particle sizes. Coarse filters are low cost. They're usually for external air. They are used in fan coils and split system. They are really for big matter. And these filters are more to protect equipment than protect people. Fine filters, now we come to what we are worried about: internal air quality and about the occupants of the building. Here's a comparison between the old European standard, the EN 779, and the new ISO standard. So there was a replacement from they used in the past 0.4 micrometers to make the test of the filter. Now they use a range of particles. That's quite similar to what MERV does. And different pressure drops, and the classification changed. Now we classify the filters as ISO PM1, ISO PM2.5, ISO PM10, and ISO coarse. And we will see that in the next table what that means. So for what was in the past an ISO 19, an ISO 9, pardon, it will be an ISO PM1 with at least 80% of efficiency for the particles that are in the PM1 range. If we go back to the previous slide, PM1 is from 0.3 to 1 micrometer. And that are the particles that go into our lungs. So in Europe, they now say that the installations, they should have at least in the last stage of filtration, a filter that gives at least PM1 50%, and usually that would fall into an F7 filter from the older standards. And what's different in ASHRAE? ASHRAE has the MERV classification, and what happens in ISO is in ISO they didn't divide it in ranges like you have a filter F9, F7 like the old standard. Now you say, okay, it's a filter for the PM1 and it has 85% of efficiency. So that the result from the test was 85% of efficiency. They have some round ups to keep it from 5 and 5%, and like the closest 5%. So if it's 81%, it will be classified as 80%. And it's quite easier to understand the filter. You go directly to the number and you get what it's giving. In the MERV class, we have some range and they're pretty close. There are some articles that show that if you do the test in different labs, it can fall in one range or the other range. So that was like because the classification was too narrow. So it's much easier with the ISO because we just gave the result of the test directly, and you have that in the code of the filter. And here I will thanks Blue Heaven, because years ago they made this comparison between the existing standards, and hopefully they will add the new ISO to it, and that it helps us to compare the different filters from different countries and different origin to adapt it to our system, so we can look into different sources. It's like there is no fixed rule to you have to apply a MERV filter, you have to apply a EN 779 filter. We can do some equivalence between these filters, but at the end is what they get out as a result in the filtration process. If you look to the MERV filter, and unfortunately I saw in the internet some companies selling what they call COVID-19 filters, and one of these companies was selling a filter that's a MERV 6 as a COVID-19 capture filter. And the COVID-19 and a MERV 6 filter both having these particle sizes for the size for the virus, less than 10% efficiency of capturing this virus. So that's bad marketing, that's bad engineering, that's a bad approach of selling. And so don't pay more for a filter because the manufacturer is now adding a stick to it, COVID-19 filters. And we will see in the end of this sequence of videos what the international agencies are recommending for the HVAC system. So, okay, you should try to go up to a MERV 13 filter, and the MERV 13 would be that filter here. And we can see that for the particle that's close to the size of the virus, it has around 60% of efficiency. So then we will try to go a little bit up to a 14 or something like that. So this, as you can see here, we have this effect that there's always a particle size where the efficiency of the filter is smaller. So there is no something called a COVID filter, a special filter for COVID-19. Don't pay more for it. And for this cheap filters that we buy for our basic air conditioning at home that we can get in the big stores and supermarkets, definitely that are not filters designed to capture the small particles. Then we go to the range of HEPA and Hoopa filters, and that's what we see in the hospitals and what some people are saying that we should apply to every installation now. In fact, these filters have a high pressure drop, so not all installations are able to deal with it. They are not really needed in all the installation. HEPA and Hoopa come from high efficiency particle air filter, and Hoopa comes from ultra low penetration air filter back in the 50s to the nuclear program. And that's the case of a product name that turned into the name of the technology. They are widely used in hospitals, pharmaceutical industries, microelectronics labs, like everything that's where you have a critical approach to the air, we use an HEPA or Hoopa filter. They have high reliability and confidence security, and important standards, and that we will see all over the world is EN 1822, the part 1, that's the European standard, the ISO standard that came out a few years ago, and the part 2 and 3 and 4 and 5 from the EN was replaced with that. They just kept the EN for the part 1 for classification and some restrictions of testing methods. And then we have the YEST recommendation, and that's with the photometer with the particles like 0.3 and how to classify your filters with that. The important thing is that HEPA and Hoopa filters are 100% tested at the factory. That means that we at the factory we test all the filters, and so we can guarantee that they have no leakage. So they will give the efficiency that's in the label. Important about HEPA and Hoopa filters also is to respect what the supplier says as airflow. Because if we increase the airflow of a filter, and here's a good sample, we reduce the efficiency. So when he says that the airflow is 800 CFM, don't try to operate this filter at 1200 CFM. You'll have a higher pressure drop, but also will reduce the efficiency. So then you need to ask what would be the efficiency for this higher airflow. And it changes. We can use the same media with different airflows and have different results for efficiency. So that's quite important. And here we are seeing that the size of the where the virus will be around, and we can see that it's higher, efficiency is higher to capture these virus size particles than what they call most penetrating particle size. That's the particle where the filter has the lower efficiency. But now we have different standards, and what happens with the different standards? In these different standards, they use different methods to test the filter. So the European standard and the ISO standard, they use what you call test the filter at the most penetrating particle size. So it's you challenge the filter in the point that you know that he has the worst efficiency. So you have to identify what's the MPPS, you test the filter in that, and then you see anything that's bigger or smaller than this particle, you know already that your efficiency is higher. A lot in South America and USA, we use still the ES standard. We use the photometer. So we are testing a different particle size, but then we also say in the report that we are testing for an efficiency of 99.97%. But it means that in PPS it will be 99.95%, for example. Here we're showing some of the different testing methods. Scanning method from the European and ISO standard, and the leakage test that's accepted in the ISO standard and then the ISO standard and the EN standard. So you can see that this filter has a leakage here. We can see it's a test with oil thread. It has a particle of 0.3 and it goes through it. You can see it. You identify the point. You make the fixing in the filter. You correct it. You cover the damage in the filter. So that's how we do it in the factories. So looking into the classification of the filters, we have the EN standards like an H13 has 99.95%, and in the ISO it will be an ISO 35.9. But it's the same filter then, just a different name. So the countries that adopted the ISO will show it like that, and Europe still shows it with the H13. And if you look into our HVAC system, and if it's a really critical situation, what we will do in the extract air, we'll add a system that's a bag in, bag out. We use it in highly contaminated installations and in some hospitals in the isolation area. What we want to do is, the filters are inside of these boxes. There is a mechanism that we can replace this filter without touching the contaminated filter, and also without touching the internal components of this device. So it's a safety device to box. So the filter comes out at the end inside a plastic box, and you can send it to be burned and destroyed, and out without the contaminated material that's inside of it. So that's one device for a high level protection installation. Important thing is that in the filtration area, what we need to do is we need to replace the filters, we need to do maintenance. And it's quite usual that we see people going to the filter area and doing it without any individual protection devices, without face mask, without protection glasses, and without gloves. Well, this filter is retaining all this matter, that's particles and microorganisms flying around. So at least we should use a mask, gloves, put it inside a bag, and then send it for disposal. I added the helmet because in some of the big installations, we go to the machine room, and it's quite common that people hit the head in some tubes and structures. How TROX can help with the filtration? We have a wide range of filtration. We have the coarse filters, we have fine filters, we have HEPA and Hoopa, we have terminal boxes, we have casings to install these devices into ducts. So if you are doing a retrofit and you want to add a new stage of filtration in your installation, we can do that in the duct system. We don't need to do that in the air handling units. But we need to take a look into the fan if it's able to go through the pressure drop generated by these filters. But we have all these devices, and we have also bag in and bag out systems. So we are going to interrupt now the video, and we will return for the third part of the video. Please watch all the videos. See you